All right, hello once again. This is Jeff Scott from Jeff Teaches Programming. In the last video, as you can see on your screen, I completed the first version of our BMI console program that was done with object-oriented programming in mind. And I'd like to extend that right now. I'm going to extend it, and then I'm going to take the one that I extend and bring that to our GUI version. All right. And then we'll talk about the payroll one after that. So first thing I'd like to do, though, is talk a little bit about why we're even doing all this. And I found this article online. There's a lot of them like this, and it seemed pretty good. And it's called, What is Object-Oriented Design? A Beginner's Guide. I don't want to sit and read to you. The whole idea is that we want to interact in our program by the use of classes. And as they say here, at the core, it's a way to structure applications using objects. All right? That's what we've been doing. We have taken the procedural function-based programs that we did in most of our, really all of our earlier examples, and we've replaced them by creating classes, which were the blueprints for objects, which, as it says, there are entities that contain attributes, also known as data, and methods, which are basically functions inside of an object. So again, class, nothing new there. Object, nothing new there. A class is a blueprint, an object is an instance of a class. The act of creating objects from classes is known as instantiating the class. We talked about encapsulation, bundling the data and methods within an object, and restricting. I told you my little simple definition, albeit incomplete definition, of object-oriented programming. That is using public methods to manipulate private data. I've already broken those rules. I've created public data. All right? We talked about abstraction, and I mentioned that I think most people, we live our lives in an abstracted way. We only see the interface to things. And I used my car for an example, that when I take my car and back out of the driveway and put the car in reverse, all that I know is I have to shift the car into reverse. I don't know exactly what happens to make that go, and I really don't care. As it says, it simplifies interaction with a system by only exposing what is relevant. We talked about inheritance, where one class, known as a parent class or a superclass or a base class, all right, is set up so that one or more other classes called subclasses, derived classes, or child classes can inherit the attributes and methods of the parent. As it says, this supports code reuse and establishes relationships between classes. It also gives us the opportunity, if we need to change, to override those methods that are created, all right, and do them in our own way. So they've got a Python example here, but I don't think we need to go over that. We talked about polymorphism. As it says, it allows methods to do different things based on the type of object that is calling them. I used the speak method. Said if we had a class called animal, and we put a speak method in it, and then we overrode it in a dog speak method that it said bark, a cat speak method that said meow, and a bird speak method that said tweet, we could use the same name for all three different classes. All right, some of the benefits. Why do we want to do this? As it says, modularity. This is what we're going to get into in the example that we're about to go through here. Breaking software down into smaller, more manageable parts where each object manages its own state and behavior. And what's important with that too is, again, as these projects get bigger and more complex, you'll typically have more people working on them. All right, reusability. You've already seen a little bit of this. All right, we want to be able to reuse classes that we've created in different projects. There's no reason why we can't. All right. Maintainability. things are going to change over time. And again, the idea, we talked about this before, the idea is if we can keep the interface the same, we can change the implementation in the background, and anybody using our stuff is none the wiser. All right, finally, scalability. Now think about this. This isn't a great example, all right? But let's think about in BMI, what if I had different types of groups that were going to, people that were going to use BMI? Maybe I had an athlete class and a worker class or something else. And maybe a better example is the payroll example. So far, we've had what, 4 different payroll types? We've had hourly, we've had piece worker, we've had commission worker, and we've had, what's the other, salaried worker. But what if we wanted to add extra types in there? We'd be able to do that. Plus, when eventually we try to move this over to a database, all right, breaking it down and making it scalable is going to make it that much easier to work with. So what we're starting to do in here is step 1 there. Requirement analysis. Understand what the system needs to do. Step 2, identify the classes. Step 3, define the responsibilities. It goes through a bunch of terminology. We don't have to talk about it here. Step 4, determine the relationships between these. Step 5, and I'm not going to show this. I actually do know how to use UML, but I'm not going to get into that in here. All right, my hope is when I get done with this, I'm going to have somewhere in the range of 100 to 150 videos. And I don't want any more than that in there. There's a lot of things that are in this beginning C thing that I'm not going to go over. All right? And we're always refining. Now, some of the principles, again, I'm just talking about these. Notice SOLID, and that's SOLID. So single responsibility, a class should have only one, it should be about one thing, basically. Open and close principles, as it says, they should be open as far as they should be extensible, but they should be closed for modification. So once you've created them and people are using them, you want to be able to add to them, but you don't want to be able to change what's already out there. Number 3, Liskov substitution principle. Subtypes must be substitutable for their base types. A child should be able to do anything a parent can do. Number 4, interface segregation principle. Clients should not be forced to depend on methods they do not use. Finally, step 5, dependency inversion principle. High-level modules should not depend on low-level modules. All right, we should be using abstraction. Now, they go through an example in here, but I'm skipping that. Common mistakes in object-oriented design, having a class that does everything. Overusing inheritance when you don't have to. Not using abstraction when you probably should. And this idea of coupling. Notice with tight coupling, classes are too dependent on each other. That makes it hard if you ever have a reason that you want to break them apart. Break the relationship between them apart. Ways that you can do this? Yeah, there's a lot of them, all right? So as it says here on the bottom, because we're just about finished with this, and then I'm going to go into how we're going to use this in our code. Object-oriented design is more than just writing code. Sorry about that. With classes and objects, it's about architecting systems that are robust, reusable, and aligned with real-world problem solving. That's what I'm going to attempt to do here. All right. So what I'd like to do is to take this program that we've been working on, which is the latest iteration of our BMI program, and I'd like to go and add to it interfaces and abstract classes. Why do we want to do this? Interfaces, again, we talked about an interface. This is going to be an interface, but I'm going to take the definition that we used before and for lack of better words, kind of extend it. I gave this simple example of looking at a calculator, and you know what the interface is. It's the calculator. So I type in 367 and I hit the square root key. I've used the interface to do that. The implementation is how it changes that 367 into the square root of 367. I don't know what that is. That's hidden from me. That's okay. But an interface in object-oriented program is also, it represents a contract. It says, hey, this is what I have available to you, but you have to use it in this way. All right? We've talked a little bit before, but not too much, about abstract classes. All right? And abstract classes, I gave the example where we had animal, and from an animal we created a dog, a bird, and a cat. Well, animal would be an abstract class. It's a class from which we create other classes, but the class itself, you can't instantiate objects from it. I can't make an animal object. Just like if you think about it, let's say I had a bank account. All right, and from there I wanted to create a checking account, a savings account, maybe an IRA account, and other accounts. You don't walk into a bank and say, hey, I want to open up a bank account, because the first thing they're going to say is, well, what kind of bank account would you like to open up? So bank account would be another example of an abstract class. Now, again, interfaces define what a class must do. They don't show how it's done. The program that we're going to be working on here, we've created a person class, if you remember. We created a person repository class, and we created a BMI calculator class. Now we're going to create 3 different interfaces. An iPerson, typically interfaces start with the letter capital I. We're going to have an iPerson interface, which shows what we must expose from the person class. An iBMI calculator interface, which is going to be kind of our calculator contract. And an iPerson repository interface, which is going to basically be with the storage. It's the contract for that we're going to use. We're also going to create 2 different abstract classes. And I'm going to call these, I don't know, I think person abstract and BMI calculator abstract. All right, I call them base, and quite often they're used with the word base. But the person abstract or the person base is going to have common behavior for a person class, or a person, and the BMI calculator abstract or BMI calculator base is going to have the shared BMI logic. We're going to keep our classes that we had. We're going to keep the person, we're going to keep the BMI calculator, and we're going to keep the person repository. All right, so we're going to keep all those. So the idea is we're extending this program right here. All right, hopefully we'll be enhancing the flexibility by using this object-oriented design. What does this do? Well, it comes across and it helps us with these pillars of object-oriented program that we talked about before. It'll promote code reusability. It'll enable polymorphism. It'll define contracts or interfaces for classes to make sure that they implement specific methods and properties. They'll decouple those dependencies that we talked about before. Remember that C# does not support multiple inheritance. It only supports single inheritance. But through the use of interfaces, we're able to at least somewhat support multiple inheritance of behavior. All right, finally, again, we will have a cleaner type of architecture, and we're going to do that by separating our implementation from our interface even more than we're doing right now. So what I'm going to do right here, I don't know where I am for time, probably 15 minutes maybe, just about. What I'm going to do before I finish this is kind of what I've been doing before, and that is this. All right, I'm going to come in here. Everything now pretty much is closed. Okay, you can see it. And as I've done before, I'm going to come in here And where I've got this 8th iteration BMI console, I'm going to copy. And I'm going to paste. And I'm going to make a 9th iteration of BMI console OOP. All right, so there's 9th iteration, BMI console OOP. We will change the name. We will open that file up and make sure we've got 9th. There and here. We will save that. We will close that, and we will close everything else that we have here. All right, that is pretty much done. Then we will come into our program here. We will go to our solution, and we will add an existing project. That existing project, again, from our C# programs, will be 9th iteration BMI console. So we now have that. All right. So that's what we're going to use. Now, what I'm going to do, I don't have to do this, but what I am going to do is in my BMI library, I have a BMI calculator class, I have a person class, I have a person repository class. I want to keep those, but I'm going to want to add to them. For instance, I'm going to want to add an iPerson interface in there. All right. So I'm going to come back and start doing that in just a couple minutes, and I'll see you then.